Hi, welcome back to MooMooMath. Today we're going to look at graphing parabolas as conic sections. You guys have learned quadratics, but we're going to look at parabolas if they are a conic section, which means a slice of a cone. So if you have a cone, so think about a cone, it's hard to do it here, like this, okay, top to bottom, and you slice it in an angle. It's going to create an oval. But if the cone is continuous, and you slice it at an angle like this, it becomes a conic section, and that's what we're talking about. So conic sections are slices from cones. Okay, so what we're going to do today is look at 4 different types. Up facers, down facers, right facers, and left facers. And inside all of these little mouths of a parabola is a little dot, and that dot we call a focus. So the vertex is, the top and the bottom where the parabola changes directions. That's this point. And then the focus is this point that falls inside. That's very special. It's a specific distance from it, which we're going to learn today. Now, a directrix. A directrix is a line. And the directrix is going to fall equally distant from the vertex as the focus does. So if the focus is 1 unit away from the vertex, the directrix will be 2. But the difference is a directrix is a line, okay? It's a line, not a point. And the definition of a parabola is a set of all points equidistant from a line, this line, which is the directrix, and this point. So as you can see, like this point, the vertex is equidistant from both the line and the point, and so is like this point. That should be equidistant, okay? So all the points on the parabola are equidistant from the focus and the directrix. It's kind of cool. Okay, the value P is the distance the directrix and the focus are away from the vertex. So if P is 1 unit, then P is 1. And then the focal width, that is the distance, how wide the parabola is through the focus. And that's also called the lattice rectum. And I will be referring to it as both of those. So the focal width is how wide it is through the focus. This is also called the lattice rectum. Okay, we're going to need to find P in order to graph these. And P is the distance from the vertex to the focus and from the vertex to the directrix. So here's our equation, and right now we're starting with really simple ones. All of our vertexes are going to be, or vertices, are going to be at 0, 0. So this lesson is just 0, 0 as the vertex. Next lesson, we're going to shift it off the origin. Okay, so if x is squared, then we're going to have the equation 4py. Now this 4p is going to be a coefficient, and we're going to solve for p using that. And then if the x is squared, we isolate the x squared. Our vertex will be 0, 0. Our focus, which is that point, will fall inside the mouth, p, length of p away. And then the directrix will fall outside the mouth of the parabola, so it's going to be out here at negative p. And then the focal width, which is the lattice rectum, is just 4p, so it's going to be the number we see in the equation. And then the graph will either open up or down, okay? If y is squared, we've never had a y squared before, really, then we're going to isolate the y squared, and we get 4px. And again, the vertex is at 0, 0. This time the focus is at p0, so whatever p is 0. It's going to be the coordinates. X equals negative p, which is a vertical line. And then the focal width, or lattice rectum, is 4p, again, this number you see in the equation, but this one's going to face a left and right. So we're used to seeing up parabolas and down parabolas. Now the parabolas are going to go left and right if the y is squared. Okay, so when x is squared, if p is positive, then it's going to face up. If p is negative, then it's going to face, down. And when y is squared, if p is positive, then it's going to face right, which makes sense, right? Right is the positive direction on the x-axis, and p is negative, then it's going to face left. Okay, so there's a quick summary of everything. Now keep this handy because we're going to need it as we begin to graph. Okay, so second page. we've got finding the value p. So the first thing we have to do when we go to graph is find the value p. Then we're going to determine which way it faces, up, down, left, or right, by looking at either x squared or the y squared. Okay, find the vertex, and we know in these problems it's going to be 0, 0, and plot it. And then we're going to count our p direction. Inside the mouth will give us the vertex or the focus. Outside the mouth, that p distance will give us the directrix. And then we're going to plot a couple more points using our lattice rectum or our focal width. Okay, so let's start with this one. We have x squared, and it's isolated, so we don't have to move anything, is equal to 12y. So that means 4p, remember in the equation, 4p is equal to 12, so p is what? 3. So our distance is 3. Now, this is an x squared, and p is positive, so this one's going to face up. Okay, our vertex is going to be at 0, 0, because we're not adding anything to x or y. Those are the ones we're starting with. So plot your vertex. Now what we're going to do is we're going to count where our focus is. Well, the focus is 3 units up. 1, 2, 3. We said up, we said 3 units, so there's the focus. The directrix is going to be on the opposite side of the vertex, so we're going to go 1, 2, 3, and put it here. Now make this a dashed line. Why do we make that a dashed line? Because it's not actually part of the parabola, but it's a reference point, so just make sure it's dashed. Now what's the equation, or what's the ordered pair for our focus? 0, 3, which was the formula over here, right? Remember this? 0, 3. And then what's the equation for the directrix? Well, it's a horizontal line at, so it's y equals -3, it's going through -3. Okay, now our focal width is, remember, that was 4p. So our focal width is just what we see in the equation, so our focal width is 12. Now, how does this help us? Well, what we do is we go to the focus, and we want the width of the parabola to be 12. So I'm going to count 6 to the right, 1, 2, 3, 4, 5, 6. So I'm at the focus counting 6 to the right, and 1, 2, 3, 4, 5, 6 to the left. Now, those 2 points are points on the parabola. So now all I have to do is connect these, and I have my parabola. There we go. See, that wasn't so bad, was it? Okay, let's try another one. Okay, we have -8x is equal to y squared. So let's see, 4p is equal to our coefficient, which is -8. So p is -2. So p is -2. Okay, which way does the graph open? Well, let's go back and look at our first sheet. The y is squared, right? And p is negative, so it's going to face left. So this one's going to be a left facer. Okay, a vertex, we said all these are at 0, 0. So let's plot this, and we know it's going to face this way, right? Now, what do we do next? We count our focus. So 1, 2, and that's 2 to the left because we know it's a left facer. So what are the coordinates? -2, 0. Where's the directrix? Directly on the other side of the vertex. So from the vertex, count 2 to the right. Now the directrix this time is going up and down. It's a vertical line, so it's x equals 2. And then focal width. Our focal width is the absolute value of 4p, so it's 8. So from here, I'm going to count up half of that, which is 4, down 4, and those are the 2 points on my parabola, and I graph it. There we go. We got 2 of them graphed already, okay? So let's look at the next 2. Next 2, we have to do a little bit of manipulating. Okay, so number 3, we need to get the squared term by itself. So this is an x squared term, and we need to get it by itself. So I've got to multiply by the reciprocal, which is -4, right? So multiply both sides by -4, and I'm going to get -4y equals x squared. Okay, so what is 4p equal this time? 4p equals -4, so p is -1. Okay, which way does this face? Well, let's go back to our first sheet. This one is an x squared. Okay, so it's an x squared, and the p is negative, so it's going to face down this time. It's a down facer. So this one's going to face down. Where's the vertex? 0, 0. Let's plot that. Okay, our focus. We know it's facing down and P is 1, so we just go down 1. There's our focus. We go up 1, and here's our directrix. So let's dash this line all the way out. There's my directrix. What is the ordered pair for the focus? It is 0, negative 1. What's the equation? Oh, it's a horizontal line, so it's y equals what? Positive 1. And what's the focal width? Well, the focal width is just what we see in the equation, which is 4. Now remember, take the absolute value of that to get your focal width, because width is always a positive. So from the focus, I go over 2 to make this width 4, right? This width is 4. And then plot my parabola. Ooh, I should curve it a little bit more. There we go. So ignore this. That wasn't very good. A little bit tighter there. And there's our parabola. Okay, last one. Let's get this one, or last one of these. Yeah, this is the last one. Let's get the y by itself, y squared. So always get the squared term by itself. So I'm going to add y squared to both sides. So I have 16x equals y squared. Okay, it's a y squared, so that tells us that it's either up or, left or right. But 16 is what? Positive. So what does that tell us? It's a right facer. So positives are up or right, negatives are left or down, right? So hopefully that makes sense on the Cartesian coordinate plane. The vertex we know is 0, 0. So let's plot that. The focus, okay, we're going to count up how many? Well, 4p is equal to our number here, 16. So p is 4. I forgot that. Should have done that first. Okay, and we said that it faces right, so I'm going to count right 4. 1, 2, 3, 4. Left 4. 1, 2, 3, 4. So here's my directrix. Okay, so my focus is at 4, 0. My directrix is a vertical line, so it's x equals negative 4. I always look at which axis it crosses. It crosses the x-axis. The focal width. The focal width is going to be, what, 16? And so what are we going to count from the focus? We're going to count 8. So up 8, right here, down 8, right here. And this one's a little bit wider. And there we go. So now you know how to graph the basic conic section when your parabola has the vertex at 0, 0. Hope this video was helpful and you can get through the short assignments.